Tesla's most advanced robot factory. We're going to explore how AI, absolute laser precision, and nonstop automation are literally rewriting the rules of modern manufacturing. This isn't just some concept for the future. It is happening right now.
And when I say happening, I mean it doesn't stop. 24 hours a day. We're talking thousands of perfectly synchronized robots grinding away around the clock, totally driven by intelligent software. The production line literally never sleeps. And as you'll see, the insane level of precision these industrial robots can repeat, day in and day out, is fundamentally changing how vehicles are built. It's delivering consistency and speed that traditional manufacturing just can't touch.
Okay, let's dive into this. We'll map out the smart factory brain, move into the heavy machinery with the gigapress and robotic arms, explore AI quality and transport, look at battery assembly, meet Tesla Optimus, and wrap up with final assembly and testing.
Let's kick things off with Section 1, the smart factory brain.
So the journey of a vehicle begins the exact second raw materials hit the loading dock. Instantly, AI takes the wheel. It's coordinating deliveries, managing inventory, and adjusting production schedules in real time. Think of this intelligent software as the central nervous system, or the brain, of the whole operation. It optimizes almost every single movement on the floor. You know those traditional factory bottlenecks where one department is just sitting around waiting for parts? Yeah, those basically vanish. The AI knows exactly what's needed, where it's needed, and when, optimizing the whole shebang before a single physical piece is even moved.
Moving right along to Section 2, the gigapress and robotic arms.
The car chassis actually starts its life in these absolutely enormous casting machines. First up, molten aluminum gets injected into giant, high-pressure molds. Then, instead of stamping out dozens of tiny pieces, the machine forms a single massive structural component in one shot. And this brilliantly illustrates the real game changer here, replacing hundreds of individual parts with just one piece. The result? You get vehicles that are structurally stronger, way lighter, and built vastly faster. It's a huge leap forward in engineering.
Once that massive chassis is cast, we hit the true heart of the factory. We're talking hundreds, sometimes over 1,000 robotic arms, moving with blinding speed and crazy accuracy. They are performing highly specialized tasks, welding parts flawlessly, lifting heavy panels like they're made of paper, and installing components with literal millimeter precision. I mean, a single arm can pull off thousands of perfect welds every single day. It's this incredibly complex, perfectly synchronized mechanical dance that makes sure the line just keeps moving. So, looking at all those sparks flying and these massive arms tossing heavy car parts around, you might be wondering, are these massive robots the most advanced machines here? Well, it's super tempting to think so, but honestly, the muscle is only half the story. The eyes and brain analyzing everything, they're actually even more mind-blowing.
Which brings us to Section 3, AI quality and transport.
Now, what's really interesting about this is the stark contrast in quality control. Take traditional inspection. It's manual, relies on humans, and is just inherently slower. Now look at AI inspection. Tesla uses thousands of high-res cameras to inspect every single vehicle. The AI constantly compares real-time images against a flawless digital model. If there's even the most microscopic defect, something totally invisible to you and me, the system flags it instantly. What used to take dedicated human inspectors a ton of time now happens in literal seconds. It's a level of quality control that was basically impossible before. But how do all these parts actually get to the robotic arms and inspection stations? Well, enter autonomous material transport. Driverless robots are constantly navigating the factory floor. They automatically dodge obstacles, dynamically pick the fastest routes based on real-time traffic, and drop off components exactly where they're needed. Because of these smart transport systems, human workers hardly ever have to risk getting hurt moving heavy materials anymore. The parts just magically arrive exactly when the assembly line demands them. All right, let's look at Section 4, battery assembly. This is a highly specialized, super demanding zone. Building a battery pack is no joke. Robots are tasked with placing thousands of individual battery cells with an insane, unwavering precision that a human simply couldn't maintain at scale. That's immediately followed up by automated laser welding to lock in the connections. And since we're dealing with high-capacity batteries here, every single pack goes through strict safety testing before it ever moves forward to vehicle integration. It is the perfect mix of high-speed automation and totally rigid safety protocols.
Next up, Section 5, enter Tesla Optimus.
Okay, now we're getting into stuff that genuinely looks like it was ripped straight out of a sci-fi movie. Tesla Optimus is a humanoid robot specifically designed to tackle repetitive factory tasks. While those massive robotic arms we saw earlier are bolted to the floor for heavy-duty jobs, Optimus is literally built with the human form in mind. And that totally shifts our focus, right? From how cars are built today to exactly who or what might be building them tomorrow.
So the crucial point is, what is Optimus actually capable of doing? Well, it can walk autonomously through the factory, carry objects, sort materials, and directly help out human workers. And this isn't just some flashy tech demo. Tesla envisions these humanoid robots becoming a totally common sight in their factories in the coming years, taking over the dull, repetitive labor that usually leads to human fatigue or injury. It's a pretty stunning glimpse into the future workforce.
And finally, Section 6, Final Assembly and Testing.
Let's move to and see how this builds, bringing ourselves back from that humanoid future to actually finish our car. Everything comes together in a rapid, perfect sequence. At second 0, doors go on. 15 seconds later, seats are mounted. By second 30, the glass is fitted. At second 45, electronics are wired. And by second 60, the software is loaded. Every single station along this line is meticulously timed. In a highly automated setup like this, even a tiny few-second delay at, say, the seat mounting station could literally halt the entire production line. It is an absolute logistical ballet. But hey, the car doesn't just roll out the door once the pieces are slapped together. Before any vehicle leaves this factory, it has to pass a rigorous gauntlet of final checks. Software systems are perfectly calibrated, an array of sensors are verified for accuracy, complex electrical systems get double-checked, and every single car has to meet Tesla's incredibly strict quality standards. It's basically a comprehensive final exam to make sure the hardware and software are talking to each other flawlessly.
Which really brings us to the core thesis of this whole explainer, captured perfectly in this quote. The factory of the future is no longer a concept. It's already here. Tesla's robot factory isn't just churning out electric vehicles. It's completely redefining how modern manufacturing actually works. By weaving together AI, industrial robots, automation, and smart software, from the loading dock to the final inspection, they've made the factory of the future a reality today.
And that leaves us with a really profound thought to chew on as we wrap up. If AI, intelligent software, and humanoid robots like Optimus can completely run the factories of today, handling everything from heavy lifting to microscopic quality control, what role will humans play in the manufacturing of tomorrow? It's a massive shift in the history of human labor, and it's unfolding right in front of us. Thanks for joining me on this explainer, and keep questioning.